Hello and welcome to the lecture series on deep learning. Deep learning is very fascinating field and evolved in last 10 years very fast. It is becoming very popular and very complex and complicated solutions of machine learning and artificial intelligence can be solved using deep learning. In this lecture series, we will understand concepts, various problems, and later on study deep learning popular libraries like Keras and TensorFlow. Now, what is deep learning? Let us take some example to understand this. Look at some applications of real world where the deep learning is used. A group of researchers in Japan built a system using convolution neural which convert grayscale image into color images which you can see here. Another example is speech reenactment. Here, an audio clip is synthesized with a video and the lip movement in the video are synced with the sounds and words in the audio clip. Recently, students of University of Washington work on the project very successfully. They sync the lip movement of ex-President Barack Obama with some different audio clip of his different lecture. One more example or application is automatic handwriting generation, which is visible in this particular slide. You can write any text and select the style and the handwriting will be generated automatically of selected type style. Now, some other important applications are: first is automatic addition of sound to silent movies. Second is producing an image from written text description. Then classification of images, automatic driverless cars, etc. For all these applications and to understand the deep learning, we need to understand neural network. So let us understand neural network first. Neural network concept is based on the neuron of human brain. We briefly introduce concept of neuron. You can see this particular image, which is handwritten first error image drawn of pigeon brain by neuroscientist Ramon Cajal. Let's understand its components, which will make us understand the concept of neural network. If you look at the image here, the components are: first is soma, which is nucleus of the neuron. Second is dendrites, which is input to the nucleus. And third is axon, which are connecting arms to the terminal buttons, which are also called as synapse. Let us understand how it works. The dendrites carry signal or data from terminal button of another neuron. It carry these signals to the soma, which is nucleus. Now, the soma then process the data and forward it to the terminal button or synapse, which forward it further to the next thousands of neurons. This is how it moves ahead from the network and neurons till the desired output is obtained. Once the desired output is obtained, this whole network of neuron connections are considered for particular output. This is how the neural network is in brain is trained. In artificial neural network, it works in the same way. The dendrites are input to the soma and it performs computation and output to the next neuron using axon. So, till now we understood the concept of deep learning and artificial neural network structure. Now, we learn about artificial neural network and its mathematical formulation. The neural network is having one input layer and one output layer. Rest all layers between input and output layers are known as hidden layers. The hidden layer can be one or more than one in numbers. Important concept that we need to understand about the neural network are three things. First is forward propagation, second is backward propagation, and third one is activation function. Let us understand forward propagation concept now. Forward propagation is the concept where the data pass from one input layer to the output layer in forward direction, passing through hidden layer if any. The input layer may contain one or more than one nodes. Let us consider one example to understand this. Here we have a neuron having two inputs x1 and x2. These inputs are passed to the neuron through the path or connection. Each of these inputs are having weights. Here we have weight W1 and W2 corresponding to input x1 and x2. Now what is requirement of weight? Okay, the weight signify the weightage of particular input. Let us take simple practical example to understand this concept. Suppose you wish to mix two colors and you want to produce a pink color. Now, as you know, the input will be red and white to produce a pink color. But if you say red plus white produce output pink is not perfect. We need to decide the proportion or weight of each color. For example, we add 80% red and 20% white, then the weight of color red and white will be 0.8 and 0.2. Hence, we can say that pink equal to 0.8 dot red plus 0.2 dot white. Now, in many cases, we control the input and the weight using some bias. So, this bias value is used to control the input and weight. Take an example of line formula. Y equal to ax plus b, where x is input coordinate and a is slope, that is weight. If we consider bias is 0, then the line will always pass through coordinate 0, 0. But if we give bias value b and add it, then the line will deviate from origin 0, 0. So bias is used to control factor. Hence, the Z will produce the linear combination of input x1 and x2. We can say that Z equal to x1 dot w1 plus x2 dot w2 plus b. Now, instead of representing the output as linear function, we use non-linear function to achieve the output. There are several approaches to achieve this task. One of the way is using sigmoid function. The sigmoid function is applied on the output Z to get nonlinear transformation A, which is also called activation function. The activation function A is equal to 1 divided by 1 plus exponential of Z minus Z. It produces value between 0 and 1. If the value of weighted sum Z is very large, then it will produce activation value close to 1. And if it is large negative value, then it will produce activation value near to 0. You must have noticed that neural network without using activation function produce just a linear regression. But the neural network with activation function is producing value between 0 and 1, and it can be used for classification problem. It is widely used for any kind of classification problems like language classification, handwriting classification, voice classification, image classification, and so on. Just for understanding purpose, we have taken single example of one neuron. In this particular example, you can look at the figure. The input value is x1 equal to 0.1 and weighted value w1 is 0.15. The bias b is 0.40. Here, we will calculate the weighted sum value z as x1w1 plus b, which comes to 0.415. Now, the activation function A can be obtained by applying sigmoid function on z, and the value A will be 0.6023. Now, in case of two neurons, the output of the first neuron will be input for the second neuron. You can see that second neuron is having input as A1 and the weight W2 is equal to 0.45 and bias is 0.65. For example, we have taken these values. So, we calculate weighted sum for second neuron Z2 equal to X2W2 plus B2. This comes to 0.9210. Using sigmoid function, we get activation value A2 for second neuron as well. As a result, we get value for activation A2 as 0.7153. So, this is predicted value for the input value x1 equal to 0.1. I hope that this example makes you understand that however complicated neural network it may be, it processes in this way and provide output or the prediction for the input values. It was simple understanding of neural network through this lecture. We will learn more in coming lecture without some complicated neural network. We will also learn about how to work with complicated neural networks and optimize the weights and bias. We will work on forward propagation in coming lecture. Practical implementation of forward propagation we will see in next lecture using Python language. Hope this lecture was proper. You must have clear your concepts about neural network. Thank you very much.